This is our IRA major project, GANS for news recommendation. The problem statement that we dealt with was given training data on the history of news items read by various users, recommend news articles to these users. Traditionally, this is called as collaborative filtering. One example of this is Alice has read some news items on presidential elections of USA. She's now recommended a news item of Hillary Clinton. One of the methods we used is dynamic negative sampling. We represent users and items in a vector space. If the representation is good, the similarity between user representation U and item representation I must tell us how likely that user is to read that item. For training randomly sample items which are not read by user is considered as negative samples. We define following laws and train the model using stochastic gradient descent. The laws is this. Here V and V' are representations of positive and negative samples respectively. Generative adversarial network. There are two processes in this, generative and discriminative. In text retrieval, the classic relevance model of information retrieval is focused on describing how a document is generated from a given information need. Whereas in discriminative process, it considers documents and queries jointly as features and predicts their relevancy or rank order levels from large amount of training data. Minimax retrieval framework. Inspired from GANS to build a unified framework for fusing generative and discriminative IR in an adversarial setting, we call it IRGAN. Also, Minimax came for IR. For a given query QN, we have a set of relevant documents labeled, the size of which is much smaller than the total number of documents M. The underlying true relevance distribution can be expressed as conditional probability P true of D given Q, R, which depicts the relevance preference distribution over the candidate document with respect to the submitted query. Query is any specific form of user's information needs. In the case of news item recommendations, query is the user profile constructed from the past item consumption, and documents can be news items. Generative retrieval model P theta of D given Q, R. Its goal is to approximate the true relevance documents over documents P true given of document given query and relevance as much as possible. The generative retrieval model intends to minimize the objective. It fits the underlying relevance distribution over documents P true of document given query and relevance, and based on that randomly samples documents from the whole document set in order to fool the discriminative retrieval model. Discriminative retrieval model F phi of query and document. Its goal is to distinguish between relevant documents and non-relevant documents for the query queue as accurately as possible. The objective for the discriminator is to maximize the log likelihood of correctly distinguishing the true and generated relevant documents. The overall objective is we aim to unify these two different IR models, that is generative and discriminative models, by letting them play a minimax game. Algorithm for the minimax game. There is a generator P theta D given query and relevance and discriminator F phi, and we have a training data set S consisting of all the user profiles, that is user and the items that they have read before. Now we initialize generator and discriminator models with random weights theta and phi. We pre-train generative and discriminative models using the training data set. We repeat this until the IRGAN converges. Generative model generates k documents for each query queue. Now we update generator parameters via policy gradient. This happens for G steps. Then we use current generator model to generate negative examples and combine with given positive examples S. Now we train the discriminator, and this continues for D steps. The whole updation continues until IRGAN converges. Using DNS gives us a normalized discounted cumulative descent, normalized discounted cumulative gain, but it can be made better by using GANS. The parameters of trained DNS are used as initial parameters for generator. Using this generator, we generate the items to be recommended for a user. Discriminator now tries to discriminate between these and items actually read by the user. Thus, discriminator can be trained using stochastic gradient descent. Generator is trained as follows. It generates recommendations based on the embeddings learned till now. It assumes the discriminator is correct and uses the reward assigned by discriminator to train its embeddings further using reinforced algorithm. Follow the metrics that were achieved: precision at 3, precision at 5, precision at 10, normalized discounted cumulative gain at 3, at 5 and at 10. Some of the improvements that we made to the existing work are: initially we initialized the embeddings as random vectors, but then we replaced this with skip thought vectors that improved the training rate significantly. We also replaced dot product used in actual method with neural networks, but it didn't converge. Instead of dot product, we tried to use a vanilla neural network with one hidden layer, which takes concatenated vector of user and item as input. Thank you.